Most years, the inner solar system only welcomes a couple of modest comets. They streak faintly across the sky, noticed only by telescopes and astronomers. But in late 2025, something utterly different is on the horizon. 7 major comets are diving inward at once, a cosmic traffic jam never recorded in the age of modern science. One of them may even flare so bright that you won't need a telescope, just your own eyes at dawn or dusk. And among them lurks the interstellar heavyweight 3, I Atlas, a visitor from beyond our solar system, swelling larger by the week. The question is this sudden convergence of icy wanderers just a cosmic coincidence, or a warning sign that our solar system is entering a turbulent chapter? 7 comets, each with its own story, each with its own path, are now racing toward the inner solar system. PanSTARRS, Swan, Stereo, Atlas Quiens, the interstellar traveler 3 I Atlas, Lemon, and 240p Neat. Astronomers describe it as a frozen masquerade, a grand icy ball in the sky, where 7 wanderers share the same stage within just a few months. To understand how rare this really is, consider history. The last time astronomers even came close to such a swarm was more than a century ago, back when telescopes still recorded on glass plates and most comets were spotted by chance. Statistically, having 7 bright comets in a single season is about as unlikely as winning the lottery multiple times in a row. That's why astronomers call 2025 not just unusual, but once in a generation. The 2025 comet season begins quietly with C2022 N2 PanSTARRS. It reaches perihelion on July 31st, more than 8 astronomical units from the Sun, far beyond the orbit of Mars. At that distance, sunlight is weak and its icy surface barely stirs. Only the most sensitive telescopes can track its faint glow against the darkness. For astronomers, PanSTARRS marks the outer boundary of this unusual swarm, the soft opening act, before the brighter, more dramatic arrivals still to come. C2025 R2 Swan was first detected on September 11th, 2025, and reached perihelion almost immediately the next day at 50 astronomical units from the Sun, about 75 million kilometers from the Sun. Its most dramatic moment arrives on October 21st, when it will pass Earth at just 25 AU, roughly 37 million kilometers. That close geometry makes it one of the prime candidates for observation this entire season. Forecasts suggest a brightness around magnitude 6 to 7. Faint but within reach for binoculars. For Northern Hemisphere observers, the comet will climb nearly 40 degrees above the southeastern horizon at civil twilight, offering excellent pre-dawn viewing opportunities. Astronomers note that Swan's rapid motion and close encounter with Earth make it a rare chance to study how a comet interacts with both solar radiation and Earth's magnetosphere in real time. The next arrival is 414p Stereo, set to swing around the Sun on September 27th with a perihelion distance of 52 astronomical units, about 78 million kilometers. Unlike Swan, its orbit dips below the ecliptic plane, making it difficult to observe from the ground. For most telescopes on Earth, the comet will be lost in the Sun's glare. Instead, spacecraft imaging will take the lead. The Stereo mission, for which the comet is named, is positioned perfectly to capture its low solar pass, offering scientists a unique vantage point. For astronomers, 414 PanSTARRS represents a different kind of opportunity, not a spectacle for backyard observers, but a laboratory in space to study comet-sun interactions hidden from Earth. C. 2025 K1 Atlas will reach perihelion on October 8th at a distance of just 0.33 astronomical units, about 49 million kilometers from the Sun. That is closer than Mercury's orbit, placing the comet deep inside the solar furnace. At such proximity, its icy nucleus will be subjected to extreme heating, triggering rapid outbursts and dramatic tail development. For astronomers, Atlas K1 is expected to be one of the most dynamic members of the 2025 swarm. Its orbit and brightness changes could shift within hours, making it a prime target for continuous monitoring by both ground-based telescopes and space observatories. For skywatchers, Atlas K1 might be difficult to see directly, lost in the sun's glare. But for scientists, it offers a rare laboratory to study a comet pushed to its physical limits. The interstellar traveler 3I Atlas is the true wildcard of the 2025 comet swarm. Unlike the others, its trajectory is hyperbolic, meaning it is not bound to our Sun and will never return. From Earth's perspective, 3I Atlas reaches superior conjunction on October 21st, slipping behind the Sun, and perihelion follows on October 29th at 1:36 AU, about 203 million kilometers from the Sun. Just inside the orbit of Mars, early measurements suggest a nucleus between 320 meters and 6 kilometers across. But its coma, the glowing envelope of gas and dust, has already expanded to nearly 700 kilometers, almost the size of Jupiter. Spectroscopy reveals unusual chemistry, a coma dominated by carbon dioxide, with little water vapor and only faint traces of cyanide. These are fingerprints rarely seen on local comets, hinting at its foreign origin. For astronomers, 3I Atlas is more than just a visitor. It is a messenger from another star system, carrying material forged in a different cosmic neighborhood, a chance to study the chemistry of worlds far beyond our own. C. 2025 A6. Lemon takes the stage in early November, reaching perihelion on November 8th at 0.53 astronomical units, about 79 million kilometers from the Sun. Forecasts place its brightness around magnitude 4, and possibly as bright as 3.5 dark skis. That puts it right on the edge of naked eye visibility, especially for observers in the northern hemisphere. Unlike Swan, Lemon will appear in the evening sky, hanging low in the southwest after sunset, from November 6th through the 12th. Its coma and tail are expected to grow steadily brighter each night. For many casual skywatchers, Lemon may be the easiest comet to see in years, a rare invitation to step outside after sunset and witness a piece of the solar system in motion with your own eyes. The final member of the 2025 swarm is 240P Neat, a periodic comet that will reach perihelion on December 19th at 2:12 astronomical units, about 317 million kilometers from the Sun. At such a distance, 240P Neat will remain faint, far too dim for naked eye viewing. Only sensitive telescopes will be able to pick up its small, hazy glow against the backdrop of deep space. Still, its presence is important. By year's end, 7 comets will have passed through the inner solar system, an extraordinary crowding of icy visitors not seen in the modern era. For astronomers, 240 Pniat closes the curtain on a season unlike any other. A reminder that even the faintest members contribute to the story of this once-in-a-generation cosmic performance. When a comet approaches the Sun, solar radiation heats its frozen nucleus, releasing streams of gas and dust that form two distinct tails. The first is the dust tail, a broad, pale streamer shaped by sunlight and gravity. It curves gently along the comet's orbital path, glowing with scattered sunlight. The second is the ion tail, a narrow, electric blue filament made of charged particles, swept away at hundreds of kilometers per second by the solar wind. It always points directly away from the Sun, no matter the comet's direction of travel. For scientists, the ion tail is more than just a beautiful plume. It acts as a living map of the Sun's invisible magnetic field, a natural probe revealing the restless energy streaming through interplanetary space. Sometimes, a comet's ion tail doesn't last. In a sudden event known as a tail disconnection, the entire structure can be severed in minutes, drifting away like a discarded ribbon in space. The cause lies in magnetic reconnection. As a comet plows through the solar wind, it occasionally crosses abrupt shifts in the interplanetary magnetic field, often triggered by coronal mass ejections or the heliospheric current sheet. These are not gentle encounters. The magnetic field can rotate by 90 degrees or more in minutes. The comet's plasma environment cannot adjust quickly enough, and the old tail is cut loose, while a new one begins to grow, aligned with the changed solar wind. One of the most dramatic examples came in April 2007, when the Stereo spacecraft captured a coronal mass ejection slamming into Comet Encke. The ion tail was severed cleanly, with the old tail floating away, a textbook case that matched magneto-hydrodynamic simulations frame by frame. Behind the scenes, a debate is unfolding among solar physicists. Some argue that comets diving near the ecliptic could actually influence the Sun itself, nudging it toward more frequent or intense outbursts. The NASA CCMC modeling team has run magneto-hydrodynamic simulations suggesting that dense, active comets crossing the heliospheric current sheet or plowing through a coronal mass ejection can rapidly shift magnetic geometry and trigger classic tail disconnection events. But not everyone agrees. Teams from the Solar Orbiter and Parker Solar Probe point to their in situ data, showing that most tail disruptions are subtle, shaped more by small-scale turbulence and background variability in the solar wind than by headline-grabbing CMEs. For now, the jury is still out. What is clear is that the 2025 swarm provides a rare chance to test both views in real time, turning the sky into a live laboratory for one of the Sun's most enduring mysteries. With so many comets diving near the ecliptic during solar maximum, space weather officials are watching closely. Each close pass raise questions about how plasma, dust, and magnetic turbulence might ripple through the solar wind. The concern is not about comets striking Earth, their paths stay well clear, but about what they leave behind. Disrupted magnetic fields and enhanced plasma flows can interfere with satellites, radio signals, and even power grids back on Earth. At the same time, the swarm offers an extraordinary opportunity for observers on the ground. Citizen scientists armed with binoculars or backyard telescopes can join professionals in monitoring sudden outbursts or tail disruptions, contributing real-time data to a global campaign. For the public, the 2025 swarm is not a threat, but a reminder our planet is tied to a larger, restless system, and watching the sky can reveal just how dynamic that connection truly is. For Skywatchers, the 2025 swarm is more than a scientific headline. It is an invitation to step outside and look up. Two key windows stand out for casual observers. On October 21st, C2025 R2 Swan makes its closest pass at 0.25 AU, glowing faintly in the pre-dawn sky. With a modest pair of binoculars, its tail could stretch wider than the full moon. Then, from November 6th through the 12th, C 2025 A6. Lemon will glow in the evening sky, low in the southwest after sunset. Forecasts place it at magnitude 3, 5 to 4 bright enough for the naked eye under dark skies. For the best experience, find a dark location away from city lights, bring binoculars, gather friends or family, and let the night sky show you a spectacle that only comes once in a generation. Forecasting comets is a lesson in humility. No matter how much data astronomers collect, brightness. Predictions often swing by 2 full magnitudes. A comet expected to blaze at magnitude 3 can fade to 5 or 6. While a faint newcomer can erupt and outshine them all, even the best thermophysical models cannot account for every hidden fracture, every unpredictable pocket of ice beneath the crust. A tiny shift in sunlight or internal pressure can change the outcome overnight. For scientists, these surprises are frustrating and exhilarating at the same time. For the rest of us, they are reminders. The universe is still full of mysteries, and nature does not bend easily to human prediction. By the end of 2025, 7 major comets will have crossed the inner solar system, a convergence not seen in the digital era of astronomy, from PanSTARRS, marking the quiet opening, to Swan, sweeping past Earth, to Lemon glowing after sunset, and the interstellar giant, 3I Atlas, rewriting what we know. Each comet has played its part in this extraordinary season. For astronomers, it is a once-in-a-generation laboratory, a chance to watch the sun and its magnetic field tested by icy messengers. For the rest of us, it is a reminder to look up. The solar system is alive, dynamic, and capable of surprises that humble even the most advanced science. Which of these comets are you most excited to see the dawn sweep of Swan, the evening glow of Lemon, or the interstellar mystery of 3I Atlas? Let us know in the comments below, and share your own plans for watching the sky during this rare season. Don't forget to like this video, share it with friends and family, and subscribe for more stories that bring the universe a little closer to home. The sky is waiting, and this year, it's putting on a show you'll never forget.